Ever feel like you're drowning in information?
Oh, yeah, totally.
It's like every day there's a new study, a new gadget, a new everything.
It's impossible to keep up, right?
Feels that way sometimes. I'm not going to lie.
It makes you crave simplicity, doesn't it?
Exactly. That's where this deep dive comes in. We cut through the noise.
Just the good stuff, right?
Exactly.
Hmm.
And today we're tackling something that's really blowing my mind. How AI is getting so much better at finding information on its own.
It's evolving so fast.
So we're diving deep into how large language models, those super smart AI text generators, are becoming experts at using search engines.
Basically giving them the keys to the internet.
Right. And our main source for this deep dive is a super interesting research paper called Search-R1, Training LLMs to Reason and Leverage Search Engines with Reinforcement Learning.
From some brilliant minds at the University of Illinois, Urbana-Champaign, and the University of Massachusetts, Amherst.
Does it get this? Search-R1 is all about teaching LLMs to think critically and to grab the very latest info from the web using search engines.
Which is huge because it means AI that doesn't just talk, but actually learns and solves problems in a much more human-like way.
Like way more dynamically than ever before.
Yeah.
So to kick things off, let's talk about what LLMs are already good at and where they struggle.
Okay, so current LLMs are amazing at understanding and creating text that sounds like it was written by a person.
I mean, they can summarize complex stuff, translate languages seamlessly, and even write creative content.
It's mind-blowing, honestly.
But here's the thing. Their knowledge is basically frozen in time.
Limited to the data they were trained on.
Exactly. So when they need really up-to-the-minute information or to tackle complex reasoning that requires the latest facts, they kind of hit a wall.
It's like having an encyclopedia that stopped being updated a few years ago. You're missing so much crucial context.
Which is a big problem if you want AI that's truly helpful in a world that's changing so fast. So how have researchers been trying to solve this problem of getting LLMs connected to the internet's constantly updated information?
Well, there have been a couple of main approaches. One is called Retrieval Augmented Generation, or RAG.
Okay, so what's the basic idea behind RAG?
So imagine you ask an LLM a question, right? With RAG, the system first tries to find relevant bits of text from a huge database of documents, often using search techniques.
Like giving the LLM some background reading.
Exactly. And then it feeds these snippets to the LLM along with your original question.
Okay, so the LLM uses this extra info to craft its answer.
Yep, but there's a catch. RAG really depends on how accurate that initial information retrieval is.
I see. So if the system pulls the wrong or irrelevant stuff, the LLM's answer is going to be off, even if it's great at generating text.
Exactly. And another thing, RAG usually only does a single round of retrieval, which isn't really enough for tougher questions that need gathering info in multiple steps.
It's just like you can only ask one question and it has to make do with that answer.
Right. It lacks that back and forth you'd have in a real research process.
Makes sense. So what's the other main strategy for connecting LLMs to search engines?
Well, the second approach basically sees the search engine as a tool that the LLM can actively use.
Interesting.
So in this setup, the LLM is either given specific instructions prompting or specifically trained to recognize when it needs external information.
And then it can figure out how to search for it.
Exactly. Prompting involves crafting instructions to guide the LLM, but it's tricky to make those prompts work well across all sorts of tasks.
To bet.
And trained approaches need tons of high-quality data showing the whole search and reasoning process, which is really hard to create and scale.
So both RAG and the search as a tool methods have their pros and cons.
Yep. And that's where Search-R1 comes in.
This is where it gets really interesting.
Oh,
right?
absolutely. Search-R1 brings something totally new to the table. It uses reinforcement learning, or RL, to teach LLMs how to interact with search engines in a way that's much more sophisticated and independent.
Independent, like they make their own decisions about searching.
Exactly. Instead of just retrieving and generating or relying on preset examples, the LLM learns by itself how to generate search queries as part of its reasoning process.
Wow. So it's not just being told what to search for, it actually figures out what it needs to know and then searches for it.
That's the beauty of it. This learning by doing sets it apart. It's not passively taking in information, it's actively leading the charge.
I love that. So what are the key things that make Search-R1 so innovative?
Well, firstly, Search-R1 sees the search engine as part of the learning environment in reinforcement learning.
Okay.
Think of it like this. You're teaching a robot to navigate a maze.
Okay, I'm with you.
The robot takes actions, right? And the
Right.
maze provides feedback based on those actions.
Right.
In Search-R1, the LLM takes actions like generating text and making search queries, and the search engine, which represents all the information online, gives feedback through the information it finds.
So the LLM is learning how its searches affect the information it gets back, and ultimately how well it answers the question.
Exactly. Secondly, Search-R1 is all about multi-turn search and reasoning.
Multi-turn, so it's not just one and done.
Nope. The LLM can search multiple times, look at the results, refine its understanding, and then do even more searches if it needs to.
So it's having a research conversation with the internet.
I love that analogy. And this is all thanks to special tokens like search, information, and information.
What do those do?
They basically guide the LLM, telling it where search queries start and end and where the retrieved info is.
Ah, so it can keep track of the different stages of its research.
Exactly. It's a much more human-like way of finding information.
Way more nuanced. So what's the third innovation?
The third big thing is the reward system in the reinforcement learning.
The reward system.
Yeah, Search-R1 actually uses a surprisingly straightforward outcome-based reward.
Meaning what?
It mainly cares about whether the LLM's final answer is right.
So no reward for clever search queries or logical reasoning steps.
Not really. The researchers found that just focusing on the final answer being right or wrong was enough for the LLM to learn how to generate effective search queries and reason its way to the correct answer.
It's amazing how powerful simplicity can be. So we have the LLM learning by interacting with the search engine, doing multiple rounds of searching and reasoning and getting rewarded, mostly for getting the final answer right. But how does the actual reinforcement learning work its magic here?
So at its heart, reinforcement learning is like the LLM experimenting with different actions.
Like trying out different search queries and reasoning paths.
Exactly. And it gets feedback based on what happens after those actions.
Right.
In Search-R1, that feedback comes from the reward function, which we know is mostly about the correctness of the final answer.
So the LLM's mission is to learn the best strategy to get those rewards.
Right. Think of it like training a dog with treats.
I love that analogy.
The LLM tries different things, search queries, reasoning steps, and if it gets closer to the treat, which is the correct answer, it's more likely to try those things again.
So trial and error, but on a supercharged automated level.
You got it. And there's this really clever technique called retrieved token masking that helps keep this learning process stable.
Retrieve token masking.
Yeah, so when the LLM generates text that includes both its own thoughts and the stuff it finds online, the reinforcement learning process mainly focuses on the parts the LLM created itself.
Meaning its reasoning and its search queries.
Right. The stuff from the search results is basically ignored during the main learning phase.
Why is that so important?
Well, the idea is to make sure the LLM learns how to reason and search effectively, not just memorize or rely too heavily on whatever it happened to find in that specific instance.
So you want it to learn how to think for itself, not just parrot information.
Exactly. And what specific reinforcement learning algorithms did they use in Search-R1?
Yeah, I'm curious about that.
They use some well-established ones like proximal policy optimization or PPO and group relative policy optimization or GRPO. PPO is known for its stability during training, while GRPO can sometimes learn faster by comparing different responses.
Gotcha. So did all this fancy footwork actually pay off?
Oh yeah, big time. The results were seriously impressive.
Tell me everything.
So they tested Search-R1 on 7 different question-answering datasets, and it showed huge performance gains compared to older methods, across-the-board improvement.
Like how much better are we talking?
For instance, with the Quen 2.57b model, they saw an average improvement of 26%.
Whoa, that's a big jump.
The Quen 2.53b model showed a 21% improvement, and even the LMA 3.23b model got a 10% boost.
Those are some serious gains. And these improvements held true for all kinds of questions, including those that need multiple steps of reasoning.
Absolutely. It wasn't just about remembering facts. The improvements were clear on data sets that specifically test multi-hop reasoning, where you need to connect different bits of information to get the right answer.
So it's not just a one-trick pony.
Nope. And get this, Search-R1 actually outperformed other reinforcement learning methods that didn't use search.
Wow, so adding that external knowledge really makes a difference.
A huge difference. And the best part, it worked well with both base LLMs and instruction-tuned LLMs.
Meaning what?
It means this technique is super versatile. It can boost the abilities of different types of large language models.
That's amazing.
Yeah.
So beyond just the overall performance numbers, What other interesting insights did the researchers uncover?
Oh, they dug into all sorts of fascinating details.
Like what?
Well, for one, they directly compared the two reinforcement learning methods, PPO and GRPO.
Head to head.
Yep. They found that GRPO usually learned faster.
So it got to a good level of performance more quickly.
Right, but PPO was more stable across different LLM designs. GRPO sometimes got a bit wobbly in certain cases.
So it's a trade-off between speed and stability.
Exactly. They also looked at the differences between base LLMs and instruction-tuned LLMs.
And what did they find?
Well, as we mentioned earlier, instruction-tuned models started off stronger.
Makes sense.
Huh.
They're already better at understanding and answering questions.
Right. But here's the kicker. With enough training-based models, could catch up to the instruction-tuned models in terms of final performance.
Wow. So even a basic LLM can learn to reason and use search really effectively with the right training.
Exactly. It shows the power of this learning method. They also looked at how the length of the LLM's responses changed during training.
Interesting.
At first, the responses were pretty long and sometimes unfocused. But as the model got better at using search, the responses became shorter and more on point.
So it learned to be more concise and personalized.
You got it. It's like it learned to cut to the chase.
Love that. Anything else?
Oh, yeah. They also confirmed how important that retrieved token loss masking technique is. Remember we talked about that?
Where it focuses on the LLM's own generated content.
Right. They found that using this technique consistently led to bigger improvements and smoother training.
So it's a key ingredient for Search-R1's success.
Absolutely. And to really show how this works in the real world, they included a cool case study.
I love case studies. Spill the tea.
They looked at a question about the fragrance Curious and who launched it.
Yeah.
A model trained without search actually guessed Beyoncé.
Oops.
But Search-R1, with its ability to search and reason in multiple steps, correctly figured out it was Britney Spears.
Nice.
It even did a follow-up search to double-check her birthplace.
So it was like, hold on, let me just verify that.
Exactly. It highlights how being able to search and reason iteratively lets the model correct its own mistakes, just like a human researcher would.
That's so cool. Okay, so let's recap what we've learned about Search-R1 in this deep dive.
The big takeaway is that Search-R1 is a huge step forward in making LLMs smarter by letting them use search engines effectively.
It's not just about feeding them information, it's about teaching them how to find and use information as part of their thinking process.
And this multi-turn back-and-forth approach, driven by reinforcement learning and a simple reward system, lets LLMs overcome a lot of the limitations of older methods.
So what does this mean for our listeners who are all about getting knowledge quickly and efficiently?
Well, this kind of progress could totally revolutionize AI systems. Imagine AI assistants that aren't limited by what they were originally taught.
AI that can research any topic, stay totally up to date, and help us with tasks that need both logic and real-world knowledge.
It could change how we learn, do research, and interact with information in our everyday lives.
That's a pretty exciting future. So here's a final thought for you to ponder. Imagine a world where AI doesn't just give you answers, but actively investigates and learns alongside you.
What amazing things could we achieve if we had AI partners that could truly explore and discover with us?
And for those of you who want to geek out on the technical details, the researchers have shared the code and trained models for Search-R1 on GitHub.
It's a great opportunity to dive deeper and maybe even build on this awesome work.
We'll include the link in the show notes. So until next time, keep exploring, keep learning, and keep diving deep.
See you in the next deep dive.